Today we'll see how to solve the homogeneous differential equation. So let me first explain you what exactly is homogeneous equation. So function f(xy) is said to be homogeneous if the function f lambda x lambda y will give you the same f(xy). That means if in the function you are putting in the place of x, you are taking lambda x and lambda y, and you are getting the same function. So this condition, or you can also say if you are putting x as lambda x and y as lambda y, and you are getting the result lambda to the power n f(xy). So if you are getting any of these two forms, then this type of differential equation is known as homogeneous differential equation. So let's say we have this question, x dy equals to x plus y dx. So here you can see that if you will take dy by dx, then in the numerator you will get two terms, and in the denominator you will get just one term. So it will be easier for you to do it. But if you make it like dx by dy, so it will become x by x plus 1. So that time solving this one will become difficult. So we'll take this first one only. So here you can see you can't separate the x together with dx and all the y together with dy. So here, and first let's check this if it is homogeneous or not. So you can see here we can take lambda x lambda y divided by lambda x. So here you can see that you will get the same thing. That means it is a homogeneous equation. So this thing you have to show as well in your like exam. So here we get this thing. So it's same as f x y. It is just x. So now we need to solve this one. So here I've taken this one as dy by dx equals to x plus y divided by x. So here what I'll do, you can see here what we have here. So that is the y dy by dx. So that means I'll take y equals to vx. Then my dy by dx will change. So dy by dx will become v plus x dv by dx. So this thing we will put in the place of dy. So that will be v plus x dv by dx, and that will be equals to x plus vx divided by x. So from here we'll get, so from here we will get v plus x dv by dx equals to 1 plus v. So here you can see if you'll simplify this thing, so it will become very easy. So it is x dv by dx equals to 1 only. So now you can separate the v and the x. So you will get dv equals to dx by x. Now you can integrate this thing. So here we'll get v equals to log x plus c. So now you can put the value of v back. So you'll get y by x equals to log x plus c. So you can write the answer as y equals to x multiplied by log x plus c. So that will be the answer. Now let's see another question. This is question number 2. 2y e to the power x by y dx plus y minus 2x e to the power x by y dy equals to 0. So let's see this question. Here we have, I'm now separating the dx and dy. I'm taking that side, so I can write this thing as this. Now here you can see on the right side we have two terms. Here we have only one term in the left. So we can write this thing as dx by dy. Okay, here I can write this thing as 2x e to the power x by y minus y divided by 2y e to the power xy. So here see, if you take dy by dx, so like in the denominator you'll get two terms, in the numerator you will get one term. So in these type of cases you have to avoid the situation where you will get more terms in the denominator. So here we'll get dx by dy. So as before I was telling you, so here in these kind of equations what we are going to take is x equals to v y. Now first let's check if it is a homogeneous equation or not. So now you can see this is your lambda, so this is your f x y, and now we can find out f lambda x lambda y. So here what we will get, in the place of x I'll just put lambda x e to the power lambda x divided by lambda y minus lambda y divided by 2 lambda y x lambda x divided by lambda y. So here you can see a few things will cancel out. So like this lambda is cancelling with this one, this will cancel with this one. In the numerator you can take lambda common, so you will get lambda common. So here you'll get 2x e to the power x by y minus y divided by, from the denominator you just have a lambda and then you have 2 y e to the power x by y. So here you can see that your f lambda x lambda y is same as the f x y. So that means therefore this equation is homogeneous equation. So if in the question it will be asked like prove that it is a homogeneous equation, so that you will do that process only. So now as I told, we have dx by dy. So we have here dx by dy, that means we will take x equals to vy. So our dx by dy will become v plus y dv by dy. So in the place of dx by dy we can put this value v plus y dv by dy equals to, and in the place of x we are going to write vy. So here we'll get vy e to the power vy divided by y minus y divided by twice of y e to the power vy divided by y. So now we can simplify it and we will get here 2vy e to the power just v minus y divided by twice of y e to the power v only. So this we will get here, and now we can simplify this one. So here you can see you can take from here y common, and in the denominator also you have y, so the simplified form of this will be twice of v e to the power v minus 1 divided by twice of e to the power v. So that is the thing which we are going to get here, and you can further solve it. So you will just get v minus 1 by 2 e to the power v, and now we'll get, so overall you'll get in the left side we have this y v vy dy by dy equals to v minus half, and this is e to the power v. Now we can cancel out this v with this v, so now we will separate all the y and v together. So we will get ev dv equals to minus half y dy, and now we can integrate this one. So you get e raised to the power v equals to minus half log y plus c, and now we can put the value of v back. So as we took x equals to vy, so from here you can see you can write v as x by y. So this thing we can replace here. So y I'm writing as x by y, v I'm writing as x by y. So here we'll get this one, and this will be the solution for our homogeneous equation. So this is the answer for this question.